Day 4, module 9 here. So we're looking at, again, calculating probabilities, but we're going to really focus on our learning goal is calculating conditional probabilities. So that's our criteria is whether or not you can calculate things that have conditional probability. So again, that is what we're looking at. We're looking at taking care of calculating probabilities on certain conditions for this. So the idea of conditional probability is it's just probability with some condition or some situation that I already know what has happened. So again, that word conditional is meaning some situation that has already occurred at that point in time. Notation with this, you guys are going to see the probability of A/B. This slash means given, or you can think of it as if something else happens. So this reads left to right, the probability of A if B has happened, or given B has happened. Okay? So we're just going to work through these. A lot of these are just examples, and you can see what we're looking at with that. But that's our goal, is to be able to calculate the probabilities of these conditional probabilities. Okay. So we're going to define what A, B, C, and D are. You guys can see we've got a standard deck of cards of 52 cards. We're going to let A be an ace, B be a black card, and C be a club, and D be a 10. Again, if you do not know what's in a deck of cards, let's make sure you guys are good with that. So here's some images of those. If you're not sure with that, you guys can always look those up. So I've got these cards. I got 4 aces, 4 twos, 3s, 4s, 5s, all the way up to kings. And that is what is in my deck of cards. So if I'm looking here, this is asking what is the probability of getting an ace if it is black. So I'm only looking at the black cards. So if I go back to my deck of cards, I'm only looking at these ones that are black, which there's 26 of them. That's the only thing I'm looking at. And I'm wanting to know what's the chance out of those black cards. So essentially I can get rid of all these red cards right now. If I'm looking at just those 26 cards, what's the chance of getting ace? And there's 2 of them. Okay? So this would be, again, out of 26, because there's 26 black cards, and then 2 of them that are black aces. So this is the black. And then this is the aces and black. So this would be like the intersection for those. So that would be my answer, except you could go 1 out of 13, or you could do again, you could go out of, do it as a percentage if you'd like to as well. Okay? This next one's asking what's the probability of being a black card if it's a 10. Okay, so I need to know the 10s will be my denominator because I'm only looking at the 10s. And then my numerator is going to be a black, the amount of black and 10s. So if I go back here and look at how many 10s there are your 10s. And there are 2 of them that are black. So I have 4 total cards that I'm looking at, and then 2 black 10s, or 1/2 would be my answer for that one. So sometimes it's easier to write these and kind of see it from that perspective, but you got to read left to right. Okay, this one's probability of it being a club if it's an ace. So I'm looking at just the aces, and I know how many clubs are aces as well. So as far as just the aces, if I look at those, I've got 4 aces, and there's 1 that's a club. So this would be 4 total aces, and 1 of them is a club and an ace at the same time. So that would be my answer for that. Okay? This one's what's probably going to 10 if it's an ace. Well, there are 4 aces, and think about this one. If they're all aces, I can't give a 10 as well. So this would be 0 out of 4. Or again, 0% chance of that occurring. Either way you want to put it. This next one, what's the probability of a black card if it's a club? So there are 13 clubs, and of those clubs, all 13 are black. So it'd be 13 out of 13, or 100% chance of that as well. And this last one here, what's the probability of getting a 10? Again, if it's a club. So there are, again, 13 clubs. And if you go back into this, again, if you need to pull this up, again, 13 clubs. And I'm looking for a 10. There's one of them that's a 10. So I'm no longer picking out of the full group of 52. Just picking out of subgroups. Okay, so that goes for every time you see these slashes. So we're going to look at a couple different scenarios, but it's the same idea as you go through this every single time. So this next problem here, I've got a 6-sided die, and it's asking what is the probability of getting a number less than 5 if it's even. So think about how many evens are on your die. There are 3 even numbers, again, 2, 4, and 6. And how many of those, again, of those even numbers, again, this would be 2, 4, and 6. How many of them are less than 5 from that? So that would be 2 and 4, so that would be 2 out of 3. That would be your answer for that one. Okay, different scenario. Let's say I've got this set of numbers 1 through 8, and I want to find the probability of getting an odd number. Well, this is no longer a slash, so this is out of 8. And odd numbers, I have 1, 3, 5, and 7, so 4 of those, or 1/2 for that one. And then I can come to this. What's the probability of getting an odd number, or a prime number if it's odd? So I look at just the odds. That's the 1, 3, 5, and 7. So there are 4 odd numbers. And how many of those are prime? Well, 7 is, 5 is, and 3 is. So it'd be 3 out of 4 for that. Okay? Let's keep looking at these. Again, same thing, just different situations. I've got a box of three blues, 5 reds, and 4 whites. So what we have 12 total. So I have 12 total here. And we're drawing one of them. What's the probability of getting a blue if it's not white? So I'm getting rid of the whites. So it has to be blue or red. So I only have 8. And what's the chance that it's blue out of those? It would be 3 out of 8. Because I'm just drawing from the blues and the reds. Okay, this next one's probability of getting not a red if it's not white. So I get rid of all the whites. And I'm looking at just these again. So out of 8, what's the probability of not getting a red? Well, that's the same thing as blue. So guys, this is the exact same question as the one above, just worded a little bit different. Okay, these next few, I've got integers 10 through 50. So if you think about this, guys, there are 41 numbers because you got to count 10 and 50 for that. Not just 40, there are 41 numbers. So 10, 11, 12, 13, 14, all the way up to 50. So this is asking what's the chance I get an even number if the number is greater than 40. So how many of those numbers are greater than 40? Well, I have 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. So there are 10 numbers. And what's the chance that is an even number? So that'd be 42, 44, 46, 48, and 50. So there's 5 of those. So this would give me a 1/2 or 50% for that one. What's the chance on B here? Greater than 40 if it's an even number. So if I look at the even numbers, there are 21 of those. Again, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, and 50 would be 21 numbers that are even. And how many of those are greater, of those even numbers are greater than 40? So it has to be greater than that, 40 and even. So that'd be 42, 44, 46, 48, and 50. So there are 5 of them there as well. So 5 out of 21. And then these last ones, numbers between 20 and 40. There are 21 of those because you got to count both 40 and 20. And how many of those are prime? So prime numbers between there would be 23. 29, 31, let's see, 37, And that would be it. So there's 4 of them from there as well. Okay. Sounds a little bit harder because you got to count them. If you need to write them out, do that, please. That'd be a good idea too. Right. Here we go. We got a coin that's tossed. If it's a heads, you go to box 1. If it's a tails, you go to box 2. And it tells you what's going on here. So what's the probability going to black if the coin falls on heads, which means I'm going to go to box 1. So if I'm looking at box 1, it contains 1 white and 1 black. So that'd be 1 out of 2 would be what would happen for that. This B, what's the probability of a white coin if it is on tails? This is box. So that's saying if I draw from box 2, essentially. There's 2 whites and 1 black, so this would be 2 out of 3 for that one. Okay, let's look at tables. Sometimes the tables are a good thing to make sure we're good with this as well. So I've got this table about students that how much sleep they got and whether they passed the test or not. There are 120 students. So this question number 12, if you select one student at random, what is the probability that you select a student that failed the exam if they got more than 6 hours of sleep? So my notation would be they failed and then slash more than 6. That's what we're looking at. So I'm looking at just the ones that got more than 6. Well, more than 6 would be this 98. So I'm only looking at those 98 students and how many of those failed. And then, again, that would be 8 out of 98. And again, you can simplify that, no problem that way. But that's how we do this. If they got more than 6 hours, I'm looking at just those that got more than 6 hours of sleep. 13, if we select one student at random, what's the probability that you select a student that got less than 6 hours of sleep if they failed the exam? So this one I've got less than 6 slash failed. So now I'm looking at those that failed, so that'd be out of 18. And out of those at 18, less than 6 would be 10. So this is 10 out of 18. Okay? Looking at this one, what's the probability of getting somebody that's got more than 6 hours of sleep if they failed the exam? So I'm looking, again, those that failed the exam. So this would still be out of 18, and we'd have 8 that got more than 6 hours of sleep. And then number 15, what's the probability they pass the exam if they got more than 6 hours of sleep? So now I'm looking at this 98 again. And if they pass the exam, that would be 90 for that. Okay, let's practice one more. This is favorite sports to watch. Be careful. This one does not have some of the totals that we have on the one side. So just to make sure we're going to add these up here. So this is going to be 77, and then 12 plus 16 plus 45 would give you 73, and that would mean your total would be 150 here. So here's your total column. So this one we're selecting one person. What's the probability that they're male if they like football? So if they like football, it'd be out of 52. So the denominator is going to be 52, and then 40 of those are male. What's the probability of selecting somebody that likes basketball if they're female? So I'm looking at just these 45 females. So this would be out of 45, and then this would be 16 for that. Because 45, whoops, sorry, my bad. This is why I wrote those down, sorry. It'd be out of 73, sorry, out of those that were female. Female are 73, and then I look at just the ones that like basketball would be 16 as well. Okay? This next probability of them being female if they like baseball. So I'm looking at those that like baseball, which would be out of 60. And those 60, which ones are female? 45 of them. Okay, what's the probability of female if they like basketball? So I'm looking at just the ones that like basketball again. This would be 38. And out of those, which ones are females? That would be 16. And then this last one here, what's the probability of somebody liking football if they're male? I'm looking at just these males, which are 77 males. And out of those 77, which ones like football would be 40. Okay, and that would be my probability of selecting each one of those as you guys go through those. So, all right, that's conditional probability. We'll see you.